Hello everyone, and we're here to do an optimization problem, AP Calculus AB, and we're asked to find the area of the largest isosceles triangle that can be inscribed in a circle of radius 6. Our first question is solved by writing the area as a function of h, which is right there. So in here we have our drawing right here, and this is our h. That's supposed to be our h, and our radius is 6 because this is our middle point. What we're going to do is we're going to find h through the standard formula, since our area is equals to base times height divided by 2 for a triangle. And what we know is, back at top, that we form a triangle right here, a right triangle, so we can do that to find our base. So down here we're gonna draw. I'm gonna draw it again. So let's say that's the middle the triangle above there. This is height, this is 6, tells you there, and this is b. So what we're gonna do is base squared is equals to 6 squared minus h squared, because of the Pythagorean theorem. To solve for b, we're going to square both sides, so we equal to, it would equal to b is equals to the square root of 6 squared minus h squared. And since we only solve for this b right here, we need to know this b as well, and it says it's an isosceles triangle, so that means we're just gonna have to multiply our b twice. So basically our b is equals to 2 times 6 squared minus h squared. So we're gonna put that in our equation now. We're gonna put that in our equation for a. So our area is equals to 2 times the square root of 6 squared minus h squared times y. Y is this right here, and it already told us that the height from the point is 6, so that's 6 plus the height because of the triangle. So that's going to be our y, so that's 6 plus y all over 2. Since we already have the 2 here and the 2 here, that will both cancel each other out. Oh, I'm sorry, I meant to say 6 plus h here. And so now our equation is the square root of 6 squared minus h squared times 6 plus h. There you go. Okay, so that would be our answer for letter A. For part B, we are, let me go back there. For part B, we are asked to solve the area as a function of alpha. So in the question, they gave us alpha is right here. We got this question from all the way from the book, by the way. So I'm going to redraw this again. Hold on a second. Oh, okay. I'm sorry, guys. That's not alpha. This is alpha. They told us that in the book. So what we're gonna do is do the same thing. Area is equals to base times height divided by 2, and we need to know, we already know height is equals to 6 plus h, so we already know that. And if you guys remember from your geometry that inscribe angles, if the angle A is half the central angle 2A, so that means we have to multiply it to get the central angle. So so in here, our triangle from above, this has to be 2 alpha, and this has to be h, and this is 6. So from there we're gonna use our sine and cosine, our sine value. So what you're gonna do is sine of 2 alpha is equals to opposite over hypotenuse. So the opposite is b. There's the opposite, and hypotenuse is 6. So b, we're gonna solve for b now. B is equals to the sine of 2 alpha times 6. Sine of 2 alpha times 6. And we're going to plug that in our equation again. So it's going to end up as a is equals to 2 times sine 2 alpha times 6 multiplied by the quantity of 6 plus h all over 2. Really, you can just ignore the 2's because it always gets canceled out. So our whole equation now is sine of 2 alpha times 6 is multiplied by 6 plus height. That is our answer for letter B. And for letter C, for letter C, we are asked to identify the type of triangle of the maximum area. So we need to find the maximum of our area. The maximum is, since our area from letter A, our area is equals to the square root of 6 squared minus 8 squared times this 6 plus h. We're going to have to find the derivative of that. So a prime is equals to the a prime of this is, I suggest you guys need to use a calculator. So what we did is we used our TI Inspire CX CAS to figure out the derivative of this whole thing, and we got out this whole thing right here. So what that ends up as the square root of 36 minus h squared minus h times 6 plus h all over the square root of 36 minus h squared. And we have to solve for h. So now we're gonna set this whole prime equal to 0. So what we're gonna do is we're going to multiply both sides by the denominator. Hold on for a sec. First, we're going to add this whole thing, 6 plus h, all over square root of 36 minus h squared. So all I did was I added this whole thing to both sides. So now we're gonna solve for h. So we're gonna divide both sides by the square root of 36 minus h squared over 1, and do the same thing here. Or what I could do is I could just multiply both sides like that. So now we ended up with 36 minus h squared is equals to h times 6 plus h. So from there, I'm going to distribute. I'll have 36 minus h squared is equals to 6h plus h squared. And I will end up with 36 is equals to 6h plus 2h squared. And we can set this equal to 0. 0 is equals to 0 is equals to 2h squared plus 6h minus 36. And if you factor that out, we'll have h, h squared plus 3h minus 18 is equals to 0. And we'll have, if you find the 2 points for that, we'll have h plus 6 and h minus 3 is equals to 0. So we'll end up with h is equals to negative 6 and h is equals to 3. And since we're working on a real problem here, we can't have a negative number, so this cannot be our answer. Our answer is h is equals to 3. And if you plug that in your area to find the maximum, since we're asked to get the maximum, we'll get area is equals to the square root of 6 squared minus 3 squared times 6 plus 3 parentheses, and our answer will end up as 27 times the square roots of 3, or it's also 46.765 units. Units squared. So to make sure reader knows, there's our answer, and that is it, guys. Thank you. Please comment, rate, subscribe. This is a really hard problem. Thank you so much for bearing with us through. Thank you.